We are going to pick up where we left off. So far, we have learned to simplify log and exponential expressions. We haven't really done a lot with solving the equations. So equations means it has an equal sign. And so we're solving for x, or solving for the variable that's inside the equation. And most often, the x is located in the exponent. So there's two methods that we're going to do today. One will work sometimes, and then the other one will work every time. So it's going to be your preference on which one you want to use by just looking at it. So the first one I'm going to show you is, so we have two methods. And the first one I'm going to show you is the one when you can get them to have the same base. This is the one that I prefer. So I always try this first. I think you might prefer this one too. The only time that it doesn't work is if you can't get them to have the same base. So we'll look at different examples of when it does work and when it doesn't work. So the first step is that you're going to get the same base on both sides. And you kind of have seen this before. We just haven't formally done an equation with it. And then we're going to set the exponents equal to each other. Then solve for x. I'm not going to write that step because that seems intuitive. So here we have example number 1, where the bases are 1/8 and then 4. And you can put like 4 to the first power if you want, but it's implied that it's just a 4. And I want to make the 1/8 and the 4 be the same base. So what base do they both have in common? 2. Because you've got 1/8 and then you have 4. I can reduce both of them to 2. Okay? So how would I represent 1/8 with a base of 2? It's 2 to the what power? -3. Good. 2 to the -3 power is 1/8. And how would I represent 4? 2 squared. So the only thing that you can't forget is to keep this x plus 1 on the outside. So it's like raising a power to a power. So this -3 gets multiplied or distributed to this x plus 1. So it now becomes 2 to the -3x minus 3 equals 2 squared. And now that they have the same base, I can set these two things equal to each other and just solve for x. So I would say -3x minus 3 equals 2. And so x equals what? -5/3.
Wait, where did you get the
-3? Wait, which one? The very first one?
Yeah.
I changed this 1/8 to have a base of 2.
Okay.
So 2 to the -3rd power is equal to 1/8. So I just changed it,
Okay.
converting it to the same base. Okay, let's try the next one. So I've got 27 and I have 1/9. So by just looking at it, what base do they both have in common? 3. So if I change the 27 to be a base of 3, what is that? 3 to the 3rd. And then if I change 1/9 to have a base of 3, what is that? 3 to the -2. Good. Good. And I put them both in parentheses. I leave the x minus 4, 2x plus 1. Second step is I now multiply them. So 3 to the 3x minus 12 equals 3 to the negative 4x minus 2. And then what do I do next? Set exponents equal to each other and solve. So x equals 10 over 7. Okay, this example 3 is a little different because it's a fraction. So just looking at the two bases, is there any way that you could make them the same base? And it will be a fraction.
You could flip one of them, like you could do the reciprocal of 3 and 4 and then square each of them.
Square one.
Yeah, but like you could do the negative.
Yeah. So if I wanted to make the base, so you want to flip it. So I want to make it 4/3.
Want it to be negative.
So I would have to raise it to the what power to become 3/4? Just negative 1. Negative 1 just flips it.
If you did it to the negative second, would it equal 16 over 9? Or do you have to simplify the other side too?
You have to simplify. You don't have to simplify the other side. If you kept them both, like if you're trying to go bigger, if you want it to be 16 over 9, then you have to think about going backwards, like how do I get to 4/3, which would be 1/2. So you always want to go to the smaller number instead of going from big to small, because then you start dealing with fractions. You don't want to deal with fractions. So I'm always thinking, like when I choose my base, like here, I'm choosing that they're 3 and then I'm going bigger, like to 27 and to 9. So I always want to choose the smaller number so that I can apply an exponent to make it bigger. That makes sense. So if I put 4/3 on the other side, how do I get from 4/3 to 16 over 9? Positive 2. Because I'm saying, how do I go from 4/3 to 16 over 9? So I'm just representing it in a different way. And then I write the x plus 2 and the 3 minus x. Okay, so now try solving for x. Okay, you should get x equals 8. Positive 8. You distribute the negative 1, so you get negative x minus 2. Then you distribute the 2, so 6 minus 2x. You set them equal to each other. I moved the 2x over here to get a positive x. Then I added the 2 over here to get a positive 8. So this one works every single time, but if you can get them to have the same base, like 27 and 9, then I suggest doing the first method. If you had like 27 and 17, well, 17 can't have the same base as 27. They can't both go to 3. So that's when you have to use logarithms. So the first step is you're going to isolate the exponential term. And the second step is you're going to take the log of both sides. And it's going to be, and this may not make sense when I write it, but once we do an example, it'll make sense. But you're going to take the log of one of the bases. So for instance, if I had 3 to the x equals 5 or something, then I'm going to take log base 3 of both sides. Which, like I said, it may not make sense right now, but it will in a second. So just have that there in your notes so that you can refer back to it. And then third step is solve for x. So looking at number 1, and I'm going to scooch down a little bit. Looking at number 1, just eyeballing it, could I make them have the same base? Yes. So let's do it that way first, and then I'm going to show you the second way, just to show you that it works both ways. So if I make them have the same base, I'm just going to put same base here. What can they both have a base of? 2. So 1/8 is 2 to the what? 2 to the negative 3. And 4 is 2 what? Squared. So what do I do next? Well, what do I need to do with that negative 3? Distribute it. And then what gets set equal to each other? Good. So 2 and then negative 3x minus 3. So you get x equals negative 5 over 3. Okay, the other way is, that's why I said it works every single time, even if they are the same base. The first step is isolating the exponential term. So this is the exponential term, like a number to a power with the x in it. So it is already isolated. If it weren't isolated, and we'll see some examples, it would be like if I had a 2 out front or something, then I would need to divide by 2. Or if I had like plus 3, then I would need to subtract the 3 over. So that's what it means by isolating, is I would need to get it by itself. Right now it's already isolated. The second step is taking the log of both sides. So I'm going to look at my base, which is 1/8, and I'm going to take the log base 1/8 of both sides. So this is what it will look like. And I'll write it this way first, and then I'll show you what happens to the exponent. So I have log base 1/8, and it's kind of a little bit under, like a subscript, of 1/8 to the x plus 1 equals log base 1/8 of 4. So all I'm doing is adding a log base 1/8 in front of both of them. That's all I'm doing first. Now, if you can think back to our log rules, when you have an exponent, what happens to it? It jumps out front. And what is log base 1/8 of 1/8? Like when they have the same base in term, what happens to it? It's just 1. So it essentially cancels. So I'm left with x plus 1 equals log base 1/8 of 4. Now, I can evaluate this one. You remember simplifying, this was like an 8.2 or 8.3, simplifying a log. So I have to think, how do I get from 1/8 to 4? -2/3. You can do that in your head, but for those of us that don't like doing it in our head, it's like having like 1/8 to what power equals 4. Make them both base 2 to the -3. 2 squared. -2/3. So x plus 1 equals -2/3, and then you subtract 1. So -2/3 minus 1, combining fractions. Instead of saying 1, I could say 3/3, right? And -2 minus 3 is -5/3, which is that the same answer that we got? Yes. Now, which way did we feel like was easier? Probably the first one, right? The first one's a little bit easier. We're gonna have several examples, so we'll get some practice. But this is just to show you that it works both ways.
We're just doing 8.5C, right?
Mm-hmm. Okay, well, first time you may not get it. That's okay. That's why we've got 4 examples. And that's okay.
Maybe the third time. The fourth one.
Okay, I'm going to erase this. Hopefully that you have it. So looking at number 2, I have a base of E and I have a base of 4/5. Can they ever be the same? No, because E is that 2.718. I don't remember what it is. But it's that constant that has a decimal. So they can never be the same base. So therefore, I have to do the second method. And you can take the log of either base. I normally prefer the left side because I don't know why, but that's how my brain thinks, is I'm just going to do it whatever number is on the left. So if I take log base E, what does that say? Like, what's the same thing as log base E? ln E. And I'm going to go ahead and make a habit of knowing that this exponent jumps out front. So I'm going to put x plus 1 here. And if I took the ln of the left side, I also have to take the ln of the right side. So I'm just going to write ln of 4/5. What happens to that ln E? It cancels out because it equals 1. If you want to skip that step completely, like if in your head you're processing and I'm thinking if I'm taking the natural log of the left side, that's going to cancel. And if you just want to write x plus 1 equals ln of 4/5, that is totally fine. I'm not going to count off for not showing your work or anything like that, because it's always going to cancel every single time. Every single time. If you're taking the log with the same base as what is the base that's here, it's always going to cancel and become 1. Now, can I evaluate the ln of 4/5? Is that even possible? No, so I'm just going to leave it. I'm just going to leave it there. I can't do it. So to get x by itself, I'm going to subtract 1 from both sides. And my final answer is x equals the natural log of 4/5 minus 1. And I am done.
So you don't do, basically, you don't do anything to that fraction because it
No.
can't, since it's attached to the natural log.
The only way that you need to get a final answer is when you can evaluate the log. So what was different about number 1 that is different in number 2 is here I had log base 1/8 of 4. And by looking at that, I can simplify it. This can actually become a number, which is negative 2/3. So basically, if you can get the same base, you're going to get a numerical answer. If you cannot get the same base, like in number 2, you're going to have a log or an ln in your answer.
So the only time it's gonna be completely simplified
Is if you can get the same base.
If you can use the
Mhm.
first. Okay.
Exactly. If you cannot use the first method and you have to use the second method, listen, right here, this is big and important. You're going to have a log or you're going to have a natural log in your answer. And it's going to stay that way because you can't get the same basis, so therefore you can't completely simplify it.
So you only use the second one when you can't get the same basis.
Mm-hmm.
So your second answer will always have a log/natural log?
If you have to use the second method, meaning like you can't get the same basis. All right, let's look at number 3. So my exponential term is not isolated, meaning I have to do a few things first. So PEMDAS backwards. What do I need to do first? Add 10. Divide by 2. And what are my 2 bases? What and what? 5 and 7. Can they ever become the same base? No, they cannot. So I'm going to have to do the second method. I can take a log of base 5, or I could take a log of base 7. Let's do 5. I prefer the left side. I don't know why, just do. But if you wanted to do log base 7, you could as well. So when I do log base 5, I'm going to skip a step, and I'm going to say that 3x equals log base 5 of 7. Are we okay with jumping to that step?
Yes.
Okay. Do I need to show what I did?
No.
Okay. Okay. Because log base 5 of 5 ends up canceling. You're just left with the 3x. Okay. Now, what's my next step to get x by itself? Divide by 3. So my final answer is x equals log base 5 of 7 divided by 3.
Would there ever be a way for you to simplify?
Not without your calculator,
Okay.
because it would get you a decimal.
Are you going to teach us that?
In your calculator? No, there's no point.
And
I mean, there's really no point to all of this, but
Nope, there is.
if I write out log e instead of ln, or if I,
It won't be wrong, but I want you to be in the habit of saying if you have a log base e to write it as ln.
okay, but it won't be wrong.
No.
Okay, sometimes easier.
Okay, so now number 4, I've got 2 exponents. So I could take log base 3 or I could take log base 7. Which one do you want to do?
Let's just do the left side.
Okay, let's do log base 7. So when I take log base 7, I'm left with what on the left side? X minus 3. On the right side, what's out in front? 2x times log base 7 of 3. Okay, now I want to get x by itself. So what are some things?
If you divide by 2. Can you pull out the x and then do parentheses?
You don't want to divide by 2. Yes. What? Say that again.
So pull out the x, and then you'd be left with parentheses 2 log 7.
Yes. Okay. So when you get to this point where you have like an x on both sides, you want to get, and this question shows up a lot. So, and the process to solve it is the same every time, even though you'll have different numbers, but the process is the same. So when you have an x on both sides, the first thing you want to do is get x's on one side. So basically I want to move the 2x log base 7 of 3 over, and I want to move the negative 3 to the other side. So you want to get your x's on one side, your numbers on the other. So I'm literally going to flip-flop these. So that leaves me with x minus 2x log base 7 3 equals positive 3. From here, so second step is pull out the GCF, which in this case will always just be x. So I'm pulling out an x. And what does that leave me with if I take out the x? 1 minus 2 log base 7 of 3 equals 3. Then to get x by itself, my next step is just divide stuff in parentheses and leave it be. You're done. So x equals 3 over 1 minus 2 log base 7 3.
And why don't you do the 1 minus 2?
Because the 2 is attached to a log, so they...
So you can put that positive 1 at the end.
You could do negative 2 log base 7 3 plus 1. Yeah, if that helps. Now, how you know that you got the answer right versus wrong? If your answer on the right-hand side contains an x, you are wrong. There should never be an x on the left and an x on the right. So if your answer still has an x in it, then you are wrong. Okay, so on the right-hand side, do you see any x's anywhere? No. You have numbers and you have logs, and that is fine. Numbers and logs are good, x's are bad. So you want to get x by itself. If you follow these 3 steps every single time, it works out that way. Okay, I think that's all of them. Yes?
Next one.